Good morning, good afternoon, and good evening, folks. Welcome to today's event with Snyk. It's called Stranger Danger, Your Java Attack Surface Just Got Bigger. During today's session, we will show common threats, vulnerabilities, and misconfigurations with our speaker today, Brian Vermeer, Snyk's developer advocate. He'll also show you how to protect your application with actionable remediation and best practices for each exploit. Today's session will be recorded, and during the session, we encourage you to ask questions throughout. Brian will be checking the questions toolbar, so any question for Brian, please go ahead and enter it in that questions panel on the toolbar of your GoToWebinar application. And thank you again for joining us. Enjoy today's session, and Brian, I'll pass it over to you.
Thank you, Taylor, and welcome. I'm glad that you're here, and today I will be talking about, well, saying the dev mindset specifically for Java developers. Well, although everything I tell you, you can do that for Node.js or for Python or whatever, but today my examples will particularly be on Java. But first, we have to talk about this word, DevSecOps. The first time I was hearing this word, I was like, okay, what is this? Is this yet a new buzzword or something like that? Just put a little AI, machine learning, and all of these kind of buzzwords in the mix, and you've got a full buzzword bingo card. But if you look a little bit closer and you go back to where DevSecOps comes from, it comes from DevOps. And all these kind of things like DevOps, we're trying to do that. And think about it, with DevOps, we are trying to tear down the walls between the traditional developer organization and the traditional operations folks. Glue them together and make sure that we are better, faster, and stronger. Basically, if you're in doubt, like, am I doing DevOps? Think about this. Are you creating stuff, and are you, to some extent, responsible to put them into production? And if something goes wrong, they end up back to you and you need to fix it. Either the software, or maybe the configuration, or maybe even, well, the deployment itself. If that is the case, then you're doing DevOps. You're not creating something and throwing it over the wall so the ops folks will fix it like we did 10 years ago. No, we take responsibility. And that's what DevOps is all about. But DevOps is all about the mindset, creating stuff and owning it. And implicitly, we already care about things like modularity, maintainability, scalability, and making sure that things, well, definitely work. However, in many cases, security is not so much a first-class citizen on a developer's mind, nor on the operations side. So we should make sure that that security part is also part of our mindset, just like scalability, maintainability, and making sure that stuff runs safely. My name is Brian Vermeer. I'm a developer advocate for Snyk, and I do a lot in the community. Like, I'm a Java champion, recently became one, which I'm very proud of, and I do some stuff for the different Java communities and the DevSecOps community. But that is not important, because we are talking about DevSecOps today and why we should do this. But first, why should we do this? Because, well, we're trying to fix a problem. But what is that problem? Let me take you back into a story from, well, my personal experience, say a decade ago. A decade ago, I was working for a government agency here in the Netherlands. I'm based in Amsterdam, and I was working for one of the government agencies in the Netherlands. At that point, we developed software the old-fashioned way, and we threw it over the wall to the operations folks, which means that we basically deployed our stuff 3 times a year. And that gives you a lot of certainty. Like, if you build something, you have a lot of time to test, and basically after a few iterations, we put in, well, we called it a sprint. It wasn't yet a sprint, but a sprint to create a release. And 3 times a year, a release was created and put into production. But if you fast forward to today, and specifically in things like e-commerce, we need to release more. We need to maybe even release 3 times a day instead of 3 times a year. And that brings, well, some things with us. Because we speed things up, we are all focusing on features, getting new features out early and often, and preferably more early and earlier than our competitors, to make sure that we have the benefit within the market. However, because we focus so much on features and these are measurable, how is that with security? In many cases, a lot of developers or DevOps engineers do take shortcuts because we got pushed from our product manager so much to get this out by today. You recognize this? Well, I had that. The point is, the security focus is not so much in the app lifecycle, like when creating the stuff, when putting it into production, but there is still some sort of security team like we used to have with the operations team that is at the end of the line. It is still siloed. And you see that a security team focuses on maybe a pen test or something like that, and it takes time. And think about it. Say my sprint is 3 weeks, and I create a new killer feature that makes the difference for my company. But after 3 weeks of hard work, and we're just in time for that launch date that we want to launch it, we already had marketing on the roll to market this out, and then the security team comes up to me and says, "Sorry, dude, not gonna happen today because we found something." That gives friction, because my 3 weeks of work might end up in going back to the drawing board and doing it all over again, and that is not what I want. However, if you look at it from their perspective, we are on the same team, and we do not want to be that next big headline in the newspaper that the data from our customers are compromised and out in the open. Well, we know what happens, right? Not something that we want. So we have to play along to some extent. Say you're a Java developer. If you're working in Java, then you probably have heard of like these libraries like Spring, or maybe even you work with Spring Boot. If we look at the latest JVM ecosystem report we recently published, we saw that Spring Boot was one of the most used frameworks within Java. And if you're doing that, you're probably familiar with this. This is a Spring initializer. And with the Spring initializer, you can, well, scaffold an application that is good for you. Like, I'm just dragging and dropping or clicking the dependencies that I need to create a WebSocket, or, well, I would just want to do some REST endpoints or whatever. I click the language I want, like Java or Kotlin, do it in Maven or Gradle, and it will create a zip file for me that contains my manifest file from Maven or Gradle, but let's say it's a Maven repository, my Maven part, and it creates a bunch of stuff for me. So I can actually have already a running project without doing anything. This is super convenient for me as a developer. But let's talk about your application code. Your application code is there at the top, just above the water, because that is the part we work on. We mainly work on that. And with a Spring application, we already have this Spring Boot application, and because this is already generated and it works. It compiles. I can run it, I can deploy it. It doesn't do anything, but hey, it works. So the first thing that I do is like, hey, let's create an endpoint that gives me back an HTML page. And let's make it simple. Let's do something like this. So I create a controller with a get mapping, and well, I do something. The only problem is there's a security issue in this code. And this code is quite small. It's just, well, a handful of lines that you can see. Well, let me enlarge it for you. This is the code there. And take like 10 seconds maybe or so and look if you can see the security vulnerability. The problem is this get mapping takes a request parameter, in this case, the user. And what we do, without any form of sanitization, we write that user back to the response writer. So that means that the input is directly reverted to the output over here. This is a classic example of cross-site scripting. Because the parameter has influence on what happens, I can create a script that does something. Not something that you want. And say you have multiple developers, well, we might see this in code review, but that's already at the end of the line, just before you push it to the repository, or maybe you even push it to production. Why not take in tooling that helps you during your process? I love to work with IntelliJ IDEA, and one of the things I use is, well, this plugin, the Snyk plugin for Spring that includes Snyk code. And Snyk code already tells me like, hey, in a similar file on line 38, the user controller, we have such a mistake. And this helps me already by creating the code securely from the get-go. From the beginning, I'm already getting warnings like, this is not maybe not what you want, but not only like this is wrong, because yeah, that is important, but also it gives me opportunities to see like how other people did solve this. So using tools that help you find these things is just one thing, but using tools that help you fix it like giving you a remediation advice on how can I remediate this, is a very useful thing. It doesn't block me, it actually enables me. And if I find this early, then the security team doesn't find it and we can go on. So that is interesting. I can have tooling within my IDE to help me out. But that is just one part. You see that the icon that I use is a piece of water and the iceberg that is just above that. But as we know, there's a lot going on under the surface. Let's take a look at that, because under the surface of an iceberg, there is a lot going on. And the first thing that we're doing is we're using a lot of open source dependencies. And well, we use that Spring initializer, and Spring brings in many libraries. And these libraries, on their case, also bring in libraries, and these bring in libraries. So that means several layers deep, we depend on code that we didn't actually write. 80 to 90% of our code base is not ours. However, we are responsible for all of it because we're practicing DevOps, or better said, DevSecOps. So if something goes wrong, it's not only my code, but it's also the code that comes implicitly with the generated Spring Boot application or your dependencies in general. So if this is your code, there's a lot of stuff between it or around it that helps you create that code, because, and that's for a good reason, right? We do not want to create yet another REST endpoint or yet another corrupt repository. Now we want to put our mind to the things that are important, the business value for the stuff that you build for your company. But as my code is just a tiny little bit, the rest of it are jars that I imported via my Maven pump file or my Gradle file, depending on what structure you use. So not only looking at your code, that is just a tiny bit above the water. Also look at what you implicitly use. Okay, that's fair, but how bad is that situation? Well, let me get to a story from, I think it was 2017 already. And for the folks that are based in the United States might know of this story. Then 2017, well, the company still exists though. These were the newspaper headings. And we already see what the problem is here, right? This is a company called Equifax, and I'm not going into the company. I'm going into the actual problem. The problem is this company was using an Apache, was using Apache struts too. And at that point, it was a very well-known, well-used framework to build your stuff on top of. No problem at all. So I believe, and I'm not sure because I didn't look at their actual code, but I believe that their business code or their business logic was perfectly fine. But they were using an outdated version of a framework. So basically, the plumbing or the foundation of their application was there. They imported it. And in this specific version of Apache Struts 2, there was a vulnerability. The problem was because this vulnerability was there and it was already in production, and you might recognize that I, as a developer, or them, were just focusing on new features, on what's going on and what do we need to fix feature-wise for our customers, instead of what is going on in production already. At that point, somebody found out that they were using that outdated version, a hack was published, and they were just using that malicious hack to go into the system. They snoop around, they look around for weeks, months, maybe even longer, I'm not sure. But in the end, over 140 million US customers were compromised and their data was out on the streets. If you want to know how big that disaster was, just Google it. They settled it, I think, last year for a huge amount of money, but you can also think of, do people trust your company now afterwards? Again, I'm not going into the company, but I'm going into the hack because the hack is interesting. So I've got an application over here, and this application runs on Heroku, and I need to restart this because, well, every time I'm not doing anything for 30 minutes on this Heroku application, it needs to restart. So you see that this beach ball already is running, and I'm trying to start this up. In the meantime, I will bring you through the hack, and the hack, of course, I will do this via my terminal. Because, hey, any good hacker will do this in this terminal, not to the browser, although that's what they say in the movies. What you see here is a header. And, well, I can do a curl request to this Apache Struts application. I don't need to get into that application. I can do a curl request to this and use a specific header to do some malicious stuff. Basically using this header. And this header is a content type, as you can see. Let me enlarge it a little bit more for you so you can actually see what's going on. This is a content type. And as you can see, the value is content type, or the key is content type, and this is the value. Who of you recognizes this content type? All right, forgot you cannot answer, but that's not a problem because it's an invalid content type. It is a non-existing wrong content type. However, it turns out that if you're using this content type, well, faulty, invalid content type, you go into an exceptional flow within Apache Struts. And in that exceptional flow, for some reason, you are allowed to utilize OGNL, the Object Graph Navigational Language, which is the expression language available in Apache Struts. With that expression language, you're allowed to interfere with the projects that are in memory, or with the objects that are in memory. I can call certain methods like getters and setters, but I'm also allowed to create new objects, and that's what we're doing here. I am creating a new process builder, which basically starts up a new process. That process builder, I feed it the bash. This bash, I can feed an arbitrary command, and then I'm rerouting the output stream to an input stream, and I can show it on my screen. Let's do this, just for the sake of making fun of it. Okay, what do I have over here? I've got the struts exploits. Oh, I've got it over here. Struts exploits. And let's get the environment variable. So I will just copy paste this one and we'll show it to you. So what I'm doing here is I am using the header I just showed you, and I'm substituting the word command for the word env. And env is just a command in Linux that shows me the environment variables. However, I am pushing this to localhost 8080, and we know this one is not on localhost 8080, it's on Heroku. So let's do it on a real application. Let's move this away, and let's put the target in. So if I do this, what you see is a lot of this is going on, and then over here I see the environment variables of my Heroku pod that is spun up just yet. The thing I just run on the internet on the cloud, I have the environment variables over here. And okay, the environment variables may not be interesting, but if I can call this command, I can also maybe create a file. And with something containing a script. And then I come back the day after and I run that script. Good luck for you finding out in your logs what actually happened, because hey, I can distribute it all over again. Anyway, I'm allowed to input code, or I can execute code, or I can execute a lot of things that you don't want me to do in your application. What we can see here is that I see what the Java options are of for instance, this pod. And I can see, for instance, where the Java home is. This one is interesting because I need it for another hack that I use in a few minutes. So bear with me, we need the Java home. But you see that this is basically what happened to Equifax. And it's not the problem of Equifax. No. I think they were basically a victim. They were using this and they didn't pay attention, of course, but they were not specifically targeted because this was found, this was disclosed with an exploit, and it was already a new version out, but they didn't update it. And that's what a lot of people do. However, attackers didn't specifically target Equifax. No, they were just playing around and basically tried to do this on every single endpoint on the internet and found out that Equifax was using this outdated library, and then they were screwed. So basically, I think this is just bad luck. However, if we translate this back to your application, and then we see this big yellow ball again, say this is the jar or the ward that you put in production if we talk about Java. How much of that code is actually the code you wrote? That little piece above the water, remember? It's probably something like this. So, and we take good pride in that because a lot of people already have things in place like code reviews or pair programming to make sure that the code that we put in production is scalable, maintainable, it's good quality. Or we can say we basically do not trust our peers because, well, everybody can make a mistake. That is the politically correct reason. However, whatever your reasons are, how do you cope with all these things in the yellow part? How do you work with these dependencies that you pull in? Do you blindly take them in because Stack Overflow told you so? and once they're in, are you updating them to some extent? Are you aware of what you're actually putting in? Let's go to this example. This is a Spring Serverless example that we created some time ago, and this is a snippet. It is very bad code because a lot of duplication, but that's not the problem. 222 lines of code. However, of course, it was Spring Serverless, so we had a bunch of dependencies. In this case, 5 direct dependencies. And all these dependencies, as you know, bring in other dependencies. A Spring Boot starter is just an empty jar with a POM file that brings in a bunch of other stuff. In this case, 5 direct dependencies end up in 54 dependencies. How many lines of code do I put into production? What do you think? It's just shy of 500,000 lines of code. And think about it, we're not responsible for the 222 lines of code we just wrote as a team. We're responsible for the 500,000 lines or almost 500,000 lines of code. And of course, not all this code is accessible, or not all this code is exploitable. But do you know? Think about it. Every jar that is there on your class path can theoretically be loaded into memory. Even though it's not yet used, you see that I have an exploit like the OGNL exploit I showed you. I can load things in memory that may not have been loaded into memory if I just used the application in a normal way. Open source usage has exploded over the last decade or so, maybe even more. But think about open source the same way as you think about your own code. It is not secure nor insecure. It is code, and we make mistakes, and we need to update code. We need to maintain code, and that also means you need to maintain these open source dependencies, because attackers are watching from them. Because if there is a library that is well used among very, very many companies, hey, if there is a vulnerability in that, I have a potential victim pool that is tremendous. So one vulnerability can have many victims. And as we can see over the last couple of years, that the amount of packages in certain ecosystems has grown, well, explosively. Like if you look at NPM, yes, they have way more packages, but that means that they probably have a lot of packages that do the same thing. I think during 2019, some were halfway in 2019, they were reaching that 1 million line. So they have over 1 million packages in their registry. But still, if you look at the blue line in Maven Central, there's an increasement between 2018 and 2019 for over 100,000 packages. So they're getting more and more and more and more. And the more important statistic is that are very many vulnerabilities identified every year. Sometimes it goes down a bit, sometimes it goes up a bit, but these numbers are on top of the year before. So at this point, if you just look at 2019, the complete year of 2019, there were more vulnerabilities found in Maven Central than in NPM. That's scary. So it's something that we need to take care of, because most of the time it's not something we include directly in our Gradle file or in a POM file. No, it is an indirect dependency that you implicitly use because the framework uses it. And we all know how that's happened. And you see for Maven Central, it's almost 80%. We asked open source maintainers, and this is all from the state of open source security. We asked open source maintainers how confident they are in their own security knowledge. And 63% says, kind of. But think about it. Do you trust kinda? And do you trust kinda blindly? But we do have code reviews before our own stuff gets into production. Maybe we need to rethink that strategy, because who is responsible for security? As we can see here, it is a shared responsibility between developers, security, and operations. So DevSecOps. And if we look at the blue line or the purple line for software, but also for infrastructure, we need to, as developers, we need to take our fair share. We make the informed decision to how we solve a certain problem. And if we use a certain problem, or if we solve a certain problem, we use a package or we use some sort of code for that. But because we are making that decision, we should make an informed decision on, is this code not only working, but also is it maintainable, scalable, and secure? So security is also on our part, and not just like I'm building, security team takes care of the rest. But enough talk, let's hack again. I mean, I already showed you how this application worked with Apache Struts, but let's go into that application. I have that application over here, and let's sign up for this. So this application, I'm signing up for this, and well, I'll just use a password. One, two, three, four, five, six, of course, because hey, it's a demo application. But don't do this at home, please. No, don't save this. It's not good. Anyway, my application can create to-dos in this to-do list. And what I can do is I can create a to-do, and I can also create something funny like eat pie and use the pie sign, because I'm a little geeky, and that's funny. And put it somewhere in 9070, and well, I'd probably be hungry by now, so give it a high priority. Let's create this one. And what you see is that the pie sign is transformed into something, and that is the ASCII representation of the pie sign. So what's happening over here is that the title or the label that I use to label my to-do is going into the native to ASCII function. And a native to ASCII function is a native function that is available in the JDK. And that transforms a symbol into an ASCII representation like this. Okay, super cool, works. Hold your thoughts. We can also upload files. And this is an interesting one, because what I can do over here, I can also upload a zip file. And if I upload a zip file, it will unpack that zip file and will give the containment of the zip file in my public folder. But what if my zip file looks weird? What if my zip file looks something like this? So we're back at the terminal, and we know the Java home. What if my zip file looks like this? This zip file contains two files, a good.txt, which is basically a text file, and a second file and it has /////. Basically, it's a weird file name. But what I'm doing here, I'm doing a path reversal. I'm trying to get out of the path of the public folder, out of the path of the web server, going all the way to the root of the actual bare system. From that point, I'm going to /app/.jdk, which was the Java home I just invented from the previous hack. And I know that the native to ASCII, by default, the native to ASCII function or the native to ASCII files by default in the bin folder. So what I'm trying to do is like, hey, if maybe I can overwrite this native to ASCII function. And why is that? Because I'm using a library to unzip my stuff. And what happens is, within Java, there's no such thing as an unzip library or an unzip function. You cannot say unzip this to this destination. No, you are allowed to look into the zip entry, get the byte array out, recreate a file at a certain point. That's what you're all allowed to. But you need to do that yourself. So many people just grab a library that unzips for me. However, if that library doesn't look at, well, sanitize basically the path like I'm doing here, it might be able to overwrite something. And let's just try that. Going to the application, choosing a file, and I have the zip slip over here, opening it, and let's upload it and see what happens. In the public folder, there's that good.txt, and that good.txt is there. So I know that the unzipping worked. Good for me. However, if we know that unzipping works, what happened to the second one? Well, might be not such a mystery, but it actually worked, because this version of the zip library I'm using doesn't look at the canonical path, but actually just execute what's there. So even though the folder is public, or the public folder, it does .. It goes all the way back to the root, all the way up to the JDK. And look what's happening if I just put something in, because the complete label goes to the native to ASCII function. It doesn't matter what I'm doing here. Say hello people, and give it a due date somewhere, doesn't matter. Give it a priority. And now you see that my title is muhaha gotcha, because that is basically what my native to ASCII function says. The only thing I overrode it with was like echo muhaha gotcha. So whatever I'm putting in over here and whatever I'm doing, everything will be translated to muhaha gotcha, because I overrode something. And this is not a big deal maybe. However, it can get worse. The point over here, what I want to say is that we are using libraries that are vulnerable. So how can I prevent this? Well, let's take a look at my application over here. And already on my local system, I can do a bunch of things. I installed the Snyk CLI, and I can do something like Snyk test. And I know this is a multi-module project, so maybe I just do all projects. Let's try this. What it does, it looks at my Maven POM file. And it analyzes, with Maven, it analyzes my POM file, and it looks at the Snyk database and sees like, okay, you're using these kind of packages, and there are a bunch of things wrong with it, and this is wrong. Like, for instance, what we see here at the bottom, the arbitrary file write for archives, the zip slip problem I just showed you. And this issue was fixed in going from 3.29 release to 4.05. That is just it, because so you see that using certain tooling is good, but making sure that the tooling also enables you to make sure that it's not only blocking you like, hey, there is a problem, but also helping you how to fix things. And I do this on my local machine, but I can also do this like within my application. Or so if I'm launching Snyk over here, and I have this same application in my in my Snyk dashboard, I can go to the project and, for instance, look at the Java goof and look at the web struts. And then we see that there are a bunch of problems over here. And I can actually look into this, like, what is the actual problem? Well, as you can see here, the problem is that I can send malicious code in the content type. Point is, in this case, I connected my Git repository to Snyk, and we can automatically already generate pull requests for you that help you with that. So automatically, even if it's already in production. That is interesting. So it enables you instead of blocking you. But that was just your code, or that was the code plus the open source stuff that you're using. Oh, now I'm looking at, let's go over here. Because think about it. At the point where I went into production, probably all the code was fine. All the code was good. But you also need to work, maybe you need to work with legacy code. Like, you know, that I worked for banks that had this stuff in place that nobody dares to touch anymore, because there's no real team owning it, but there are people responsible, or people depending, customers depending on it. So nobody dares to touch it. If it runs, just keep it there. Well, at that point where it went to production, it was perfectly fine, I guess. However, over time, problems will get found. It takes time to find a problem. So how much time do you think in general it takes for a problem to get, for a security issue to get found and disclosed? This can take up to 2.5 years, which makes it interesting. So if something is good now, it might be wrong tomorrow or next week or a year from now. So if something is in production for a long time and you didn't take a look at it, and it's, for instance, outward facing, maybe you should take a look at it. So now we looked at your application code for a bit, at your open source dependencies, which make a huge difference. But then there's more under the surface. For instance, we do more nowadays with containers. And it can be a Docker container or a container created with Podman, or using the Azure repositories, or even putting something on Heroku, because basically putting my Java jar, my executable jar on Heroku is containerizing this stuff. And people think that if you put something in a container, by default it is safe because you encapsulate it. Well, let's talk about Docker containers for a second. What happens with a Docker container? Because some people think like, hey, put it in a Docker container and by default you are safe. That is unfortunately not true. Because what's happening if you're creating a Docker file? The first thing you do is from something, like from Ubuntu or from Debian or from Node.js or from Maven, whatever build you're using. You're depending your build on a build that already exists on Docker Hub, if we're just talking about Docker. This is a research I did in late 2019, and we downloaded the top 10 most commonly used Docker images that were free to use. And we scanned them for vulnerabilities. This was the result. And if I do it today, the numbers will be different, but we probably will see that a lot of these packages still have vulnerabilities. And that comes because I just downloaded the latest version, doing nothing special, just the latest tag of a certain Docker image. But these images are also based on another image. For instance, the node image is based upon, at that point, upon Debian. And this was a somewhat older Debian Jessie version. So most of the vulnerabilities were not actually in Node.js. No, they were in the operating system layer. And that makes you think, do I actually need such a large Docker container with a full-blown operating system for my application, for my simple REST endpoint? Probably not. But also, everything you pull in, such an image comes with a lot of extra binaries. And these binaries may contain vulnerabilities. And you may think you're not using them, but are you sure? Isn't there a path somewhere available that can use an exploit within a certain executable that is not related to your application? Think about it the other way around. What you don't have cannot harm you. So why should you put it in? We asked people, like, when do you scan your Docker images for open source or operating system vulnerabilities? A lot of people are not aware of that because, hey, it works, ship it. And how do I find out about new vulnerabilities in deployed containers? A lot of people don't. Well, let's hack this again. I have the same application I just showed you, and now I will put it into a Docker container. I can do that. So let me go to the Docker file. And what I'm doing here is I'm using a multi-stage build. So I'm using a Maven build to build my Docker, or to build my application. And I'm using a Maven cache to do so. So a Maven install, maybe not needed. I could do a Maven verify technically. And my production image will be based on Tomcat, just a Tomcat thing. And I will deploy the web.xml and the var in my Tomcat. Sounds legit. So let's do that. I will use Docker Compose for this, so it's right away available for me. Docker Compose -build. And Docker Compose basically builds the Docker container in this case and make sure that it's available to me through port 8080. So now it's building, it's doing a lot of stuff. Registry, fine, cool. Let's wait for a second, creating Java goof. Well, it's there. Thank God for the Maven caching, so it makes it a little bit quicker. And let's go to the browser. So let's go to localhost 8080. Oh, I already have it over here. Let me localhost 8080 gives me Tomcat, and I deployed /to-do list. This is the actual application, only it doesn't run the CSS. And as you can see from the to-do list, it's basically the same without the styling. So welcome to to-do list, and go to homepage. It's basically the same over here. Welcome to to-do list. So believe me, but it's not about the application. It is about the container. So we don't need to go into the application. The application is running, not styled, but hey, I don't care about that now because we are going to hack the container. And what I'm going to do is I want to do a arbitrary code execution again, but now within Tomcat. And basically this is what I'm executing, because this base image I'm using to run this has a Tomcat version that has exactly this vulnerability. And what we did was we just looked in the exploit database, and the exploit database showed me a Python script. That is cool. So what I can do is in this exploit, I am able to upload JSP files to the server via a special crafted request. And as you know, with JSP files can contain Java code, because Tomcat also contains a compiler. It compiles it on the fly on the server side and shows you the results client side. So what I'm doing here, I'm actually executing two functions. I can execute a normal function that basically checks if it works. It creates a JSP file. This is a Python script. So what I did was creating the Python script in a library over here. So if I do check, let me show you what I do with type check. what I do is I call the Docker container that contains this script, and I'm running this application on, well, basically my local host 8080. So let's do that. Check. And it says POC.JSP is created. It is vulnerable for CVE 2017-12-617. So let's go to POC.JSP. It wasn't there before. Well, you have to believe me in that. I didn't show you, but let me get to the application. Where was it? It was here. So if I go to the local host, or I'm over here, and let's go to that POC.JSP, POC.JSP, and it shows me exactly the A's that were predicted to me in that script, right? Exactly this. Now I'm doing a second one. I'm doing RCE, a remote code execution, by giving it a command pwn, and that will create a JSP with a form. And within the JSP, I can execute Java. And again, I'm executing a runtime with something I put into the form. So just to show you that pwn.jsp doesn't yet exist, pwn.jsp does not yet exist. However, if I go back to my exploit and I call pwn, it now uploads that web shell for me. So let's take a look if that works. Going back to the application, see if pwn is there. Hey, I inserted a JSP. And what can I do? I can call things, because now I'm just calling the runtime and actually executing this string. So if I do a who am I, I'm root. You can actually see what is in there here, like ls. That is interesting. So I can also do things like, what kind of packages are there, because it runs Linux. And basically, I've now got a shell available because I am using a container that has a malicious version or a vulnerable version of Tomcat in there. So you don't want that. And I can do all sorts of things. Like I can go all the way back to the passwd file, like complete path reversal because I'm root, and go into any file I want and see what's in there. This is all possible. This is all within the container. And now my container is running locally, but that container can also run in the cloud. Something you don't want, because now I'm also vulnerable for the exploits that come with that container. What we can do is, let's go back to my application and just let me stop this container. So let me stop it, and just for that, let me just Docker compose down. Okay, let me clear my screen. So the container is down now, and what I can see is like Docker image ls. Let's see what kind of image here is. The image is Java goof I created. Fair enough. So let's do a Snyk container test on this Java goof latest version. And I only have one, but just to make clear, latest. Okay, cool. Let's just give it a small hint. So I give it the file that is created from Docker, and it's my Docker file. It's just here in my root of my project. And let's also look for app vulns. Maybe I find something. Oh, it's app minus vulns. So let's do this. And what it does, it analyzes my image, uses also my Docker file to see how my image is built up. You can only scan the image, but if you use a Docker file, it can also give you remediation advice on how to create such a container and what is a better base image, for instance, to do that. And after analyzing, you will see that I can, for instance, find this application vulnerability that comes with Tomcat on the remote code execution. But it will also show me a bunch of other things like, hey, what kind of base image are you using and how can you be better at that? So if we just look to that log, and I just specified a lot, this is the thing we just saw, the arbitrary code execution. And the code is 451514, and we can go to that URL, and you basically see the URL I just showed you at the beginning, like open URL. Oh, that goes in another screen. but basically it opens the arbitrary code execution I just showed you with the exploit DB, right? So that is the thing, it can recognize that. And I can also upload or update just this package. But what I can do more easily is update the base image. And if we go all the way up, and yes, I zoomed this in, so it's quite big. Normally it's somewhat smaller, but I love to do this on my local machine. Let me see where the base images are. Oh, there might not be. There. Should have practiced this. No, but seriously, what we can do is we can look at base images and see what kind of base image you're using. And I'm not, well, let's look for this. I think it's 0.5.21. I cannot find it, but we can. Maybe I didn't give the right solution with it. Let me just check it again. Oh, I see why. Because I didn't do Docker file equals Docker file. Oh, let me try that again. So we'll analyze it, and it will give me the Docker file, and will give me remediation files to see that I'm using a certain version of Tomcat 8.5.21. And if I remediate to another version, most of these application vulnerabilities will be gone. We will come back to this in a second. I'll just run this, and we will be moving on for now. The same you can do in your application if you just connected your application to Snyk, your repository to Snyk. If I look into my project, and now it's not coming up. This is the demo effect. But you will see your projects over here, and you can see that it has certain vulnerabilities for certain projects, probably because, yes. So say over here, it says like, hey, there's a Docker file, and this Docker file has a bunch of vulnerabilities. And you can look at it, and it says like, hey, I'm currently using Docker 8.5.21. The best minor upgrade you can do is minor upgrade to 8.5. You might say like, but that's a downgrade. No, that's because of labeling in Docker 8.5. I think at this point it's connected to 8.5.69 or something like that. It's just another label, but it shows you which minor upgrade you can do to get rid of a bunch of severe vulnerabilities. Same results you will have over here. Hey, now you see, I'm using Tomcat 8.5.21. The minor upgrade we can do is upgrade to 8.5. I can show you that if I do that, rebuild the container, that is not that this exploit is not working anymore, but you probably believe me. Anyhow, we talked about containers. We talked about open source stuff, like your dependencies, and we talked about your code. But there is a next layer, and the next layer is your infrastructure as code. I'm not going to demonstrate this, but you can imagine that nowadays everything is code. And within your Kubernetes files that you're using to orchestrate your whole landscape, or your Terraform files, there is a bunch of stuff you can do wrong, like misconfigurations, things like running things as root, all these sorts of stuff. And we can scan that for you as well by doing, instead of Snyk container, as I did, to doing a Snyk AIC, infrastructure as code. However, but what is the solution? The solution is not just dump tooling. The solution is three ways. It's culture, process, and tooling, but they are equally important. So remember that. First of all, team culture or company culture. Make sure that we all care about the same things, because normally we don't. Developers care about making things work, building things, interesting new technologies. Security people just want to be secure, want to make sure that we will not get breached. No data will come out, and no things will be just there on the street. Not getting breached is the core KPI of a security person. If you're looking at operation folks, they think about, hey, how simply can I deploy things, or is it predictable? How can I scale it? What happens if it goes down in the middle of the night? Does it automatically revive, or do I need to get out of bed and push a button? And management, they care about deliverables and profit. But we need to take care about each other's KPIs. Like if management gives me as a developer the opportunity to learn stuff about security, but also to get rid of technical debt, fix my vulnerabilities, instead of just pushing on new features, then we already one step ahead of this. However, as a developer, I also need to take care of the security folks, because if I can already help it from the beginning, like not importing the wrong or not using the wrong container image, or not using the wrong or the vulnerable version of a dependency, that already helps the security folks getting back at me like, sorry, dude, can't work. So if we play along just like children, we are there. However, that is a mindset that is difficult, and we should start with that. Next to that, we should make sure that we look at the current process, how we build our application. What is our software development lifecycle? Because creating new process will not work unless you are breached. If you are breached now and everything is out, then everybody wants to change, because we have management up our desk like, hey, we need to solve this now, and what happened, and it will backfire on us. However, after 2 weeks or after 3 weeks, and I've been in these situations, you will go back to normal, and you will go slightly back to the point like, okay, we need to develop fast, we need to develop early, we need to make sure that this feature is out early and often. So look at your current process and make sure that your security tooling fits that process. So not creating new process, just keep the process and just adapt it a little bit. So pick the tooling that fits your process. Then you need to pick the right tooling, because we do not want to just satisfy a tool. We all know these things like in a CI pipeline, if all tests are green, I just push it. I don't care if it's just green, it's okay. I don't want to care, I don't want to think about it. That's not how we're supposed to work. If we do care about it and we take it from the beginning and we do it all the way up our development lifecycle, then we're on a good path. For instance, while coding on your local machine with an IDE plugin or a local CLI, before actually pushing my stuff to my repository, that already helps. Just like your unit test, I want to get feedback early and often. And if I find it there, hey, it will save me time, it will save the company money, and it will save me a lot of stress. But then again, connect your repository to it and make sure that every new commit or every new branch or every new pull request gets tested. Maybe automatically there's a pull request if there is a problem. But you do not want to get worse at a certain point. Maybe you're comfortable with, say, five vulnerabilities because they're never reachable. Hey, it's your code and it's your context. You do not want to get worse. So if you scan over there and you get automatically pinged if something is wrong, or if there is a new fix available, that is actively helping you instead of holding you back. Then within your CI system, you build your software, and we need to take care of that before you go into production, yes, make sure that there are, well, I wouldn't say no vulnerabilities, but as less vulnerabilities as possible. Scan the Docker container altogether that you're building before you go to production. And you can do that by automating your CI pipeline, GitHub Actions, or just using the CLI. And we have the CLI I showed you. And we have integrations with most common CLIs like Jenkins and Circle CI and all that stuff. So that's quite easy. But once you go to production, you're not there yet. Make sure that when you are in production, before you go into production, as part of your CI pipeline, do a Snyk monitor. And with a Snyk monitor, what you do is you take a snapshot of that point in time with that Docker container at that point in time and all the dependencies, and we scan it over and over again every single day. So while it's in production, you will still get scanned, because at that point it's basically static code. It's not changing anymore. And if something goes wrong or somebody finds a new vulnerability, you get actively pinged and you know, hey, I can integrate it with my Jira board and maybe I should prioritize this. So again, actively helping you and not pushing it away because, hey, it's in production, focus on the new features. Make sure that you scan in every single step of your development lifecycle. If you want to know more about best practices in coding in Java or creating Java containers, go to our blog. On our blog, we have a bunch of very, very nice assets like blog posts and cheat sheets that can help you create more secure code and create more secure Java code in this specifically. If you have any questions, feel free to ask them now. Or if you're not comfortable in asking a question now, also you can ask them later or ping me on Twitter, email me, feel free to do so. For now, I want to thank you for your attention. All right, let's take a look at the questions, and maybe Taylor can help me out because I don't see any questions at the moment. But
Actually, I don't think we have any, Brian. Last call for questions. Otherwise, if folks want to email Brian directly, that would be a great way to get in touch as well.
yeah, and I can imagine, like, most of the time when I see such a presentation, I'm like, oh, this is interesting. And then like 3 hours afterwards or the day after, I'm like, but what about this? Feel free to email me or send me a DM on Twitter, and I would kindly help you to answer these questions, or refer you to somebody else who has a better understanding of your specific use case if you have some. So
Perfect.
if there are no further questions, again, thank you for being here with me. Thank you for holding on for almost an hour, and I'm grateful that you were here. Thank you.
Thank you. Thanks, Brian. Thanks, everyone, for joining.